Hello, I'm Laura Lewis. Welcome to this GCSE exam practice on the rate of reaction and factors that affect it. Just seeing if I'm, yep, you can hear me talking. Okay, so we're looking at exam questions based on the rates of reaction and what can affect it. So we'll start off with a question and we'll get on to longer extended answer questions, which students generally find the hardest to do. Okay, so in chemistry, it's pretty important to read the question because there's lots of things going on. Sometimes there's pictures going on, there's text obviously going on, there's equations, there's lots of things. So it's very important to obviously to read through it slowly and if necessary make some notes as you go. Okay, so let's start off with reading this question. So this is taken from an exam paper, a GCSE exam paper. So a student investigated the reaction between magnesium and hydrochloric acid. Okay, so we've got a boiling tube there, most likely like a thick test tube. Magnesium, so magnesium is usually, they call it ribbon form, so it's like a thin piece of metal. So magnesium's a metal, and it's in hydrochloric acid. Okay, so you may have seen that in class, you may have seen a video of it. So if you put magnesium in hydrochloric acid, it reacts very quickly. Okay, it's very sort of vigorous reaction. I'm going to say it's not quite a violent reaction, but a vigorous reaction. And what actually produced is bubbles. So you can see bubbles there. So it's important to examine closely what they've given you. So they've always given it to you for some reason. So always think about why they've shown you that. Okay, so magnesium is reacting with hydrochloric acid. We've got the equation for the reaction is magnesium, Mg, solid. Okay, that little symbol there means solid. S for solid. Plus 2HCl, AQ, aqueous. Because all acids now alkalis would be aqueous. That means they're dissolved in water. Not liquids, they're aqueous. Okay, so magnesium plus hydrochloric acid goes to that symbol. Magnesium chloride and hydrogen. Okay, so hydrogen is gaseous form. Magnesium chloride, aqueous. So that word aqueous means that it is soluble in water because it's still aqueous, it's still dissolved in the water. Hydrogen gas. Okay, so we might have to refer to this a bit later again, but let's look at the question. Give two observations. Okay, 1 and 2, they've made it obviously 2 there. The student could make during the reaction. So an observation is what you see happening, okay, or what you can measure. So what you can see or what you can measure happening. Okay, so the first thing you can actually see happening is bubbles or effervescence. So let's insert a text box here because I've inserted this as an image. Let's just drag this. Ooh, I don't know how to do this. If I drag this down, we can write anywhere. So this is another sort of mini lesson on how to put a text box in as well at the same time. If you ever get any work, you need to write on it. So something like best is to write underneath. So we'll just write underneath for now. So 1, because this is an image. So number 1, so observation, what you see, fizzing, bubbles or effervescence. Effervescence. Okay. I'm going to write more than 2 things here, just to give you examples, but you only need 2, okay? Because usually I give you more than what is needed, so that if you even remember a little bit of this, you'll get the full marks. So that's what your teacher probably do in class, where they give you lots of examples, but you can have any of these 2 would get you the marks. Okay. So you can say the magnesium disappears or dissolves. You actually see it get smaller. Okay, because it's obviously reacting and getting smaller. 3, when I say observation, you generally think about you see it, but an observation could be a measurement. Okay, so it's actually an exothermic reaction, so it gives off heat. So you could put a thermometer in there and measure the heat given off. So it gives off heat. Okay, gives off heat. You could just say a temperature change. I mean, for that one, you have to be quite confident in your knowledge of the reaction. Okay, because not all reactions are exothermic. You can also put a change in pH. Again, you have to be quite confident. You can measure that using, that's correct the way I wrote that. You have to put universal indicator or litmus in it to do that. Okay, so these two, yeah, a little bit more advanced than these two, but any of those two would gain the marks for that because they just need a very short answer. It's not an extended answer question. Okay, so moving on from that, we're going to get to the longer one because the longer ones are going to take us the most time, okay, to do in the exam. So I think I might just, yeah, I'll put it down so we've got a new page. That's fine. So you all need to pay attention to 6 marks because obviously because there's so many marks in it, you can go wrong quite easily in the fact that you could kind of start answering a different question than what's actually being asked. Okay, so it says in this question, you'll be assessed on using good English, organising information clearly, and using specialist terms where appropriate. The student investigated how the rate of reaction changed when the concentration of hydrochloric acid was changed. Right, so there's some key points here. So the student investigated how the rate of this reaction, so we're still in the same question about the magnesium and the hydrochloric acid. So the student investigated how the rate of this reaction changed when the concentration of hydrochloric acid was changed. Is write a plan the student could use. So in your plan, you should describe how you would carry out the investigation and make it a fair test. Number 2, describe the measurements you would make. Okay, so there's quite a lot of things going on there. So let's just think about what we're actually investigating. Okay, so we're actually investigating. It's easy to get a bit lost with these. How the rate of reaction changes when the concentration, because that's what we're changing there, of hydrochloric acid was changed, or is changed. Okay, so we're doing it in present tense because we're talking about how you do it now. Okay, so let's think about this. So what can we do? So let's have to think about variables here. Okay, so I will write the variables first because then you know what you're doing. So we're going to look at the independent variable. This is kind of showing you how to plan an experiment as well as talking about the reaction. You've got sort of like a double learning experience here. Because yeah, it's also about reaction, how to plan things. So independent variable, what you change. So what you are changing, that is the you're changing the concentration. So that's what we're changing the concentration of hydrochloric acid. Okay, dependent variable, what we are measuring. Okay, so when we say the rate of reaction, we mean how fast something is reacting over time. It always involves time. Okay, so the rate of reaction over time. So we could measure the rate of reaction we could measure the volume of the gas produced, okay, or the amount of bubbles. Okay, so we're going to be a bit more scientific today. The volume of gas produced over time. Okay, and we'll go for a sensible time, like 5 minutes. Okay, as long as it's fairly sensible, they don't really mind what you write. Okay, so it's not like hours. It will finish reacting. 5 minutes is probably sufficient enough. So control variables. So they are needed. So what stays the same to make it a fair test? So what stays the same to make it a fair test? Control variable. Okay, so there's a few things we need to do. We need to use the same amount, so the same mass and size of magnesium each time. Okay, and use the same amount of acid. So same amount. So let's go back a bit more scientific. Volume. I'm pretty much sure they'd give you amount, but we're going to be very precise. Same volume of acid each time. So now we need a plan. Okay, well we can write it step by step, but in full sentences. Plan can be in steps. Okay, number 1. So need to sort of prepare different volumes. We don't need to say how we prepare them because that's not part of the question. Different volumes of acid. So example, hydrochloric acid, to be more precise there again. We'll try and be as precise as you can. For the person marking it, it's a bit easier life for them. Okay, so you could have something like 0.1 molar, 0.2 mole, 0.3 mole. Example, 0.4 mole, 0.5 mole. Okay, that's an example. Again, as long as it's sensible, it's okay. Okay, for different volumes of hydrochloric acid. So you need to, fair testing. Okay, so next one, so how we're actually going to do it. So set up, so how many have we got there? We've got 1, 2, 3, 4, 5. Set up 5 boiling tubes in a boiling tube rack. Tube rack. So add an identical, so exactly the same piece of magnesium to each boiling tube. Okay, using the first concentration, 0.1 molar, measure 20 centimeters cubed. So you can write cubed in a short form like that of acid. Add this to boiling tube and immediately attach a gas syringe. So a gas syringe that collects gas. So time 5 minutes, and note down the amount of gas produced. Okay, note down the amount of gas produced. So number 5, repeat the above process with each concentration and note the results in the table. Okay, so we've written that about how we do it. Okay, so I don't think to explain anything. So describe the measurements you would make. So we've made measurements of how much gas, how you can make it a fair test. So you stated that. It's good also to state, if you think it's obvious, to state why you're doing something. Okay, there. So yeah, if you there's a recorded video, so you can run back and have a look at what else we wrote there. So let's go on to another question. We can get another question in. Okay, so we've got a different type. Got a different question here. So it says a student investigated the temperature change. So talk about exothermic reaction. This is maybe exothermic or endothermic. The student investigated the temperature change when zinc reacts with copper sulfate solution. So we've got zinc reacting with copper sulfate. So zinc at the bottom, copper sulfate solution. It's blue. Your colour image. The student used a different concentration, so we've got different concentration again, of copper sulfate solution for each experiment. The student used the apparatus shown in figure 3. Okay, figure 3, thermometer, glass beaker, 2.3 grams of zinc, 50 centimeters cubed of copper sulfate solution. So it says the student measured 50 centimeters cubed copper sulfate solution to a glass beaker, measured the temperature of the copper sulfate solution, measured 2.3 grams of zinc, measured the highest temperature, so the highest temperature this got up to, and repeated the experiment using copper sulfate solution with different concentrations. Okay, so we've given a method there. The equation for so it's a little bit different to the other one, isn't it? Because we've been given a method now, and we'll have to sort of investigate it. The equation for the reaction is zinc solid plus copper sulfate solution aqueous goes to copper solid, so it's not soluble in water copper, and zinc sulfate solution, aqueous. The thermometer reading changes during the reaction. Let's give one other change the student could see during the reaction. Okay, so let's have a look. So what you could, so it's going from zinc to copper. What I would put there is color change. Zinc is silver, copper is like an orangey, copper color. The color change. So zinc will change color during the reaction. So you actually get a color change during that reaction. Okay, moving on to look at we're given the results table. It's a little bit different to the other question. In this question, you'll be assessed on using good English again, so it's a 6-mark question. Organising information clearly and using specialist terms where appropriate. The students' results are shown in table 1. Experiment number 1, concentration. Okay, so yeah, it's kind of like we're looking at having done kind of very similar to the other one, isn't it? We've got kind of the other end of it. So we've got concentration of copper sulfate in moles per dm cubed, or molar, as I just quoted it, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. That's a 1 molar. They've gone up to 1 molar here. Increase in temperature, 5, 10, 12, 20, 25, 30, 35, 30, and it keeps the same. Okay, so it's increasing up to 35, and then it kind of stays the same, so it plateaus, I'd call that, so it keeps the same. Okay, so yeah, let's see what it's asking us. Describe and explain the trends shown in students' results. Okay, so describe and explain. So we need to explain what is happening as well as describing. Describe means what you see going on, like describing what's happening, and explain the trends. So the trend is something that's increasing or decreasing. So let's have some description first. So the temperature change increases as the concentration of copper sulfate increases. Yeah, so that column's going up and that column's going up to a certain point. So we'll write to a certain point. Okay, that's one trend. We're going to use numbers actually with this. So the temperature peaks, so it gets to its highest point at the temperature change in temperature at 35 degrees and remains constant. 35 degrees with a 0.7 molar solution and remains constant with further concentration increases. It's always good to put numbers in like that. So 35 degrees and 0.7 because people know exactly what you're talking about. Okay. So So a bit of a reaction, bit of a sort of explanation there. So the reaction is exothermic. We can write something else there as well. The action is exothermic, so it gives off heat. Okay. So you could say, so that's the next one. So the rate, a bit more scientific now, the rate of reaction increases with concentrations. Yeah, you have to be careful what we're changing, okay? Because we're measuring temperature, we're not changing it. Okay, so we're actually measuring it. That's why you've got to be careful and sort of stop for think for a minute. With concentration increases due to, it's scientific now, the particles having more energy and more successful collisions. You're going to write, it's a lot in science, in chemistry, to react. The temperature does not increase forever. Does not increase forever as the reaction is completed when the copper sulfate reaches 35 degrees. So it's finished reacting at that point. Okay, it's finished. Okay. So yeah, it doesn't go on forever like that. I guess it's called like an optimal temperature. Even in the body, it's like that. So in the body, you have chemical reactions, and they have an optimal temperature. Usually, obviously, your body temperature. That's why it's dangerous for your body to go over or under a certain temperature, because if reactions within your own body slow down or speed up. Okay. So yeah. So when you see a graph like that, always try to explain. So describe what is going on. Okay, it's one thing I haven't actually sort of seen for a bit. Is there any anomalous results? So you've got 5, 10. These kind of got in 5. So 3 could be considered anomalous. So you could say attempt. Sometimes I'll make it a bit more obvious than that. The anomaly could be seen as an anomalous result, because yeah, it doesn't increase quite as much. So what you do to sort that is to do more experiments. So if they're asking how to improve it, you'd say you could do further experiments to see if that is truly an anomaly. Okay, so that would be another thing to do. But that's we've described and explained it. It's actually a very fortunate question to get, because it's actually quite short in answering. It's not too wordy, that one. Okay, because they're looking for sort of key statements and things there to give you 6 marks, and make sure it makes sense what you write, but it doesn't have to be an essay. Okay, for that one. So I hope you've learned something today in the class, and hopefully it will improve your 6 mark answering, because that's what students find the most difficult, is these 6 mark. But as soon as we sort of sit down and have a look and plan them, they're not too bad at all. So thank you for joining the class. I hope to see you in another one. Goodbye.